Good morning to everyone. My name is Dr. Chiripiredi Venkateswar Reddy. Currently, I am working as Associate Professor in the Department of EEE at Annamacharya University, Rajimpet, Andhra Pradesh. Today, I am going to discuss my topic with the title of Problems on Kirchhoff's Laws. So, we will see the first problem. Calculate the current in each branch of the circuit as shown in figure. So, this is the circuit they given. So I'm requesting everyone, please try to understand the problem, what they given, what we have to find. Okay. So I'm requesting everyone, please go through the problem and understand each one so that we can easily calculate what they're asking in the problem. Okay. So coming to the solution, so given data, so they given one circuit. So that is the circuit I represented here. So for that circuit, we are having two loops. So this is the loop one. So this is the loop two. So here I mentioned the current direction for both loops, loop one as well as the loop two. But here I taken always I am considering minus two plus. Okay. So that's why I taken the current direction is from minus to plus in this direction I am taken. So that is clockwise direction. So here also same thing. Here also minus 2 plus. So it is entering minus 2 plus. So on coming like this. So this is the anti-clockwise direction. Okay. So in the problem, they're asking the current in each branch. So the current in each branch, that is I1, comma I2 and I3. So why? Because we are having three branches. Okay. So this is the one branch, that is A and B. So in this branch, we need to calculate how much current is flowing. That is I1. So and one more branch is there. This is the another branch, that is BC. So here we need to calculate how much current is flowing, that is I2. So similarly, one more branch we are having, that is 2 ohm resistor, that is BE. Here how much current is flowing through the 2 ohm resistor, that is I3. So we need to calculate the current in each branch, that is I1, I2 and I3. Why? Because we are having three branches. So now applying KVL to the loop one. Okay. So that is the loop one is A, B, E, F. This is the loop one. So this is the loop two. Okay. For the given circuit, we are having two loops. So the first loop is the A, B, E, F. Okay. So for that loop, we are applying KVL. Okay. So what is the statement of KVL means? The algebraic sum of the voltages is equal to 0, or the source voltage is equal to the drop across the each resistor. Okay. So here when you are applying KVL to the loop one, that is A, B, E, F. This is the loop one. If you are applying KVL to this loop one, the source voltage, that is 4 volts, is equal to the drop across each resistance. So here two resistances are associated with the loop one. So one is the 4 ohm resistor and another one is the 2 ohm resistor. Okay. So the source voltage is equal to, that is 4 volts is equal to drop across this resistor. That means we know that Ohm's law V equal to IR. So that is the drop across this resistor here 14 into I1. That means so 14 is the R, I1 is the current. So R into I1, that is your V. That means drop. Okay. So similar way here, 2 ohm is your resistor. How much current is flowing through the 2 ohm resistor is, that is I1 plus I2. Okay. You know the current, you know the resistor. So this is also drop. So our statement is the algebraic sum of the voltages is equal to 0, or else the source voltage, that is 4 volts, is equal to the drop across each resistor. So here now 4 volts is equal to 14 into I1, because I1 current is flowing, plus 2 into I1 plus I2. Why? Because so here I1 current is flowing through the 2 ohm resistor. Similar way I2 current is flowing through the 2 ohm resistor. Okay. So here why I mentioned plus here means I1 current is coming downward direction as well as the I2 current is downward direction. That means both currents are flowing same direction. So during the time we can consider positive. Now 14 I1 plus 2 into I1 plus 2 into I2. So now 4 equal to 16 I1 plus 2 I1. This is equation number 1. Now applying KVL to the loop 2, that is B, C, D, E. For the second loop, we need to apply the KVL, that is B, C, D, E. So when you are applying KVL to the loop 2, the source voltage that is 9 volts is equal to, so the drop across the 7 ohm resistor, that is 7 into I2 plus 2 into I2 plus I1. So here why I consider I2 plus I1 means now I am talking about second loop. That's why I consider I2 first, then I1. Why plus I1 means I2 is coming downward direction. Here also I1 is coming downward direction. Both are downward direction. So that's why 2 into I2 plus I1. Now 2I1 plus 7I2 plus 2I2, that is equal to 9 equal to 2I1 plus 9I2. So similar way here also. So why I consider here I1 plus I2 means I1 we are talking about the first loop. That's why I mentioned I1 plus I2. Why plus I2 means both I1 as well as I2 both are downward direction. So by solving equation 1 and equation 2, we will get I1, I2. So now the I1 value is 0.128 amps and I2 value is 0.971 amps. So how to solve these equations means with the help of your calculator. So when you are pressing shift mode, so there it will show equation. So in that you will enter this first equation as well as the second equation. So there you need to choose how many constants are there. Here three constants are there. So in that way we need to solve in the calculator. Now we know the current I1, we know the current I2. So now current through the 2 ohm resistor we need to calculate. So how much current is flowing here, that we need to calculate. So that is I3 equal to I1 plus I2. Now you know the value of I1, that is 0.128 plus you know the value of I2, that is 0.971 amps. So by summing up these two currents, that is 1.099 amps. So here we find out all the currents. I1 we are calculated as well as I2 we are calculated as well as I3 is calculated. So in the given data they are asking to calculate each branch current. So the first branch current is the I1 and the second branch current is the I2 and the third branch current is the I3. So we completed first problem. So the next problem is calculate the current in each branch of the circuit as shown in figure. So this is the circuit they given. So here also they are asking to calculate the current in each branch of the circuit. They given one circuit. For the circuit they are asking to calculate each branch current. So if you observe this figure or else if you observe this circuit, it having three branches. So this is the first branch, this is the second branch and this is the third branch. So coming to the solution, given circuit, I represented given circuit as well as I taken direction in the two loops clockwise direction. This is the clockwise direction. So in the second loop also I taken clockwise direction. So the first loop I represented with A, B, E, F and the second loop I represented with B, C, D, E. So in the given problem, they're asking to calculate the current in each branch. The current in each branch, that is I1, I2 and I3 is equal to question mark. Applying KVL to the loop 1, that is A, B, E, F. So when you are applying KVL to the loop 1, the source voltage 4 volts is equal to 14 I1 plus 2 I1 minus I2. Why? Because here the loop 1 current is coming downward direction. Here the loop 2 current is flowing opposite to the I1 direction, that is opposite to the loop 1 direction. So both are opposite each other, I1 minus I2. So why I1 minus I2 means I am talking about the first loop, that's why I consider first I1, then what is the opposite to that one? Second loop current, that is I2, I1 minus I2. Now 14 I1 plus 2 I1 minus 2 I2. So now the source voltage 4 equal to 16 I1 minus 2 I2. So this is equation number 5. So the next one, applying KVL to the loop 2, that is BCEF. So here I shown applying KVL to the loop 2, that is BCDE. BCDE. So when you are applying KVL to this loop 2, so the source voltage minus 9 is equal to 7 I2 plus 2 I2 minus I1. So here why we are mentioning minus 9? Because the current is entering positive to negative. So it is entering positive to negative. That's why minus 9 is equal to 7 I2. The second loop current, that is 7 I2 plus 2 into I2 minus I1. So the second loop current is I2. For the second loop current, what is the opposite current? I1 is coming opposite. That's why I2 minus I1. So is equal to minus 9 is equal to minus 2 I1 plus 7 I2 plus 2 I2 is equal to now minus 9 is equal to minus 2 I1 plus 9 I2. This is equation number 8. So by solving equation 5 and equation 8, we will get I1, I2 value. So now I1 is 0.128 amps and IT is 0.971 amps. So this is the first branch current, this is the second branch current. But in the problem they are asking to calculate each branch current. We know the two branch currents now. That is I1 current, branch 1 current, as well as I2 is the branch 2 current. So now we need to calculate how much current is flowing through the 2 ohm resistor. That is I3 equal to I1 plus I2. Now you know the value of I1, that is 0.128 plus 0.971 is the I2 current. By summing up these two, you will get 1.099 amps. So this is about the problem 2. So coming to the problem 3, in the following electrical network, find the current in 5 ohm branch by applying Kirchhoff's laws. So they given one electrical network. So for that network, they are asking to find the current through the 5 ohm branch. So in the previous problems, they are asking the current in each branch. But in this problem, they are specifically asking 5 ohm branch current only they are asking. So please try to understand the problem. They given what they are telling in the following electrical network. So this is the electrical network. So in this electrical network, they are asking to find the current through the 5 ohm branch. So the current through the 5 ohm branch, this current they are asking to calculate. How will they are asking to calculate? By applying Kirchhoff's laws. So this is the electrical network. So same electrical network I drawn here, but here I represented the loop directions. So, but already I said, always I am considering the current is flowing minus to positive. So I'm always preferring this one, minus to positive. That's why I'm taking minus to positive in this direction. So here also the current I'm entering minus to positive in this direction. Applying KVL to the loop 1. So this is the loop 1, A, B, E, F. This is the loop 2, B, C, D, E. So in the network, we are having two loops. The first loop is the A, B, E, F. And the second loop is B, C, D, E. Now I am applying KVL to the loop 1, that is A, B, E, F. So when you are applying KVL to the loop 1, 60 is equal to, the source voltage is equal to 10 ohm I1 plus 5 I1 minus I2. Why I1 minus I2? I1 current as well as I2 current, both are opposite direction. That's why I1 minus I2. If both currents same direction means you will get I1 plus I2. So here I1 is going upward direction, I2 current is coming downward direction. Now 10I1 plus 5I1 minus 5I2. Now 60 equal to 5I1, sorry, 15I1 minus 5I2. This is equation number 1. So applying KVL to the loop 2, that is B, C, D, E. When you are applying KVL to this loop 2, the source voltage 40 volts is equal to 10 I2 plus 5 I2 minus I1. 5 I2 minus I1. Why? Because I2 current is coming downward direction, I1 current is flowing upward direction. Now minus 5 I1 plus 5 I2 plus 10 I2. So now 40 equal to minus 5 I1 plus 15 I2. So by solving the equation 1 and equation 2, we will get I1 and I2. Now I1 equal to 5.5 amps and I2 equal to 4.5 amps. So in the problem, they're asking to calculate current through the 5 ohm resistor. So now the current through the 5 ohm resistor is I3 equal to I1 minus I2. You know the value of I1, that is 5.5 minus, you know the value of I2, that is 4.5. So you will get 1 amps. So why I1 minus I2 means the I1 current as well as I2 current both are opposite direction. That's why I1 minus I2. So now you know the value of I1, that is 5.5 amps. Parallelly, you know the value of I2, that is 4.5 amps. Now the resultant value is 1 amps. So this is about the problem. So the next problem is the next problem is find the current in each branch of the network as shown in figure by using Kirchhoff's laws. So this is the network they given. So please try to read the problem, what they're asking to find, try to understand. So in the problem they're asking find current in each branch of the network shown in figure. For this network they're asking to calculate the current in each branch by using Kirchhoff's laws. So solution is given network. So this is the given network. So here they given the loop directions. Already they mentioned. So we need to follow the same loop direction. So whatever the loop direction they mentioned, same direction, so we have to follow. So this is the network. So in this network, we are having two loops. That is, one is the A, B, E, F, and second one is B, C, D, E. This is the second loop, B, C, D, E. Applying KVL to the loop 1, that is A, B, E. So when you are applying KVL to the loop 1, so the loop 1 is associated with 15 volts is associated. Here that the 15 volts is associated, 5 ohm, 10 ohm, 8 ohm and 5 ohm. These all the devices are associated with the loop 1. Now, so the 15 volts, 15 minus, why? Because 15, this is entering minus 2 positive and coming like this. So here it is entering positive to negative. That means, so this voltage is 15 minus 15. Why? Because here it is entering positive to negative. That's why 15 minus 15 is equal to 5 I1 plus 8. So this is the 8 I1 minus I2. Why I1 minus I2 means I1 coming downward direction. So now I2 is coming upward direction. So 8 I1 minus I2 plus 5 I1 plus 10 I1. Now 5 I1 plus 8 I1 minus 8 I2 plus 5 I1 plus 10 I1. Now 15 minus 15 is equal to 0. So 28 I1 minus 8 I2. So this is the equation 1. So that is for the loop 1. So now we need to apply KVL to the loop 2, that is BCDE. So this is the loop 2 BCDE. So here also, what are the components are associated with the loop 2? So 15 ohm is associated, 25 ohm, 15 volts is associated, 25 volts is associated, 10 ohm, 8 ohm, and 10 ohm. So now 15. Why? Because here the current is entering minus to positive. So and positive to minus. So that is 15. So why? Because it is entering minus to positive. 15 minus. So here it is coming positive to negative. So minus 25 is equal to 10 I2 plus. So this is the 1 ohm resistor, that is 10 I2. So plus 8. So this is the 8 ohm resistor, 8 I2 minus I1. So now minus 8 I1 plus 10 I2 plus 10 I2 plus 8 I2. So now minus 10 equal to minus 8 I1 plus 28 I2. This is the equation number 2. So by solving the equation 1 and equation 2, we will get I1 and I2. Now I1 equal to 0.1 amps. So and the I2 value is minus 0.3888 amps. So but in the problem they are asking current through the 5 ohm resistor. In the problem they are asking current through the 5 ohm resistor. So you know the value of current, that is I1. So 0.11 minus, and so here the current through the 8 ohm resistor. So that is, so the current through the 8 ohm resistor, that is I3 equal to I1 minus I2. You know the value of I1. So that is minus 0.111 amp minus, you know the value of I2 minus 0.388 amps. So this is the current through the 8 ohm resistor, not 5 ohm resistor. So we need to calculate the current through the 8 ohm resistor. So you will get 0.277 amp. So this is about the problem. So the next problem, in the network shown in figure, find the potential difference between X and Y. So this is the problem they given. So in the problem they are asking the potential difference between X and Y. So from this point X to Y, so the potential difference we need to calculate. So solution, given network. So whatever the network they given, so that network I already mentioned here. So, but what they're asking in the problem, they're asking to find the potential difference between X and Y. So the potential difference between X and Y is equal to question mark. So in the network, we are having two loops. The first loop is the AXCB and the second loop is DEFY. Okay. Now applying KVL to the loop 1, that is AXCB. Now source voltage 2 equal to, the source voltage 2 equal to 3I1, the 3I1 plus 2I1. Now 2 equal to 5I1. So in the from this we are going to calculate I1 value. Now I1 equal to 2 by 5, that is 0.1 amp. So this is for the loop 1. Applying KVL to the loop 2. Applying KVL to the loop 2. So what is the loop 2 here? DEFY. So when you are applying KVL to the loop 2, the source voltage, what is the source voltage here? 6 equal to, why it is 6 I consider, it is entering minus to positive. 6 equal to 5I2 plus 7I2. Now 6 equal to 12I2. From this we will calculate I2. I2 equal to 6 by 12, that is 0.5 amp. But in the problem, they are asking to find the potential difference between X and Y. So that is the drop across the X and C. Voltage drop across 2 ohm resistor, that is VXC. So V, sorry. we are in the problem they're asking to calculate the potential difference between X and Y. So that is the potential difference. The voltage drop across V and XY is equal to, so from this point to this point, that means we need to know this point drop as well as this voltage we know, as well as this drop we need to know it. So now the drop across 2 ohm resistor, that is VXC, VXC plus, you know, the voltage they given here. So that is VCD, VCD they given. So minus PDY, PDY, Y minus, so potential difference means, so from one point to another point, we need to subtract. So that is VXC minus VDY. So here Y I consider plus VCD means, so it is entering minus to positive. So that's why I taken VCD. So if the polarities are reverse, that means plus here minus here means, so during the time you need to consider minus. So now the drop Vx means voltage drop. So 2, what is the resistor? 2 into I1. How much current is flowing here? I1 current is flowing. 2 into I1 plus, so VCD voltage, they already they given. What is the voltage? 5 volts they given. Minus 5 into I2. 5 into, what is the current is flowing here? 2 ohm. That is 5 into I2. Now you substitute the values of I1 and I2. You know the value of I1 and I2. So 2 into 0.41, that is the I1 value, plus 5 minus 5 into 0.5. So after simplifying this one, you will get the potential difference between VXY is equal to 3.3 volts. So like this, they will ask the problems. So some more problems is there that we will see the next video. So some of complicated problems are there. So they will ask in terms of bridge rectifiers. So some more difficult problems they will ask. So first try to understand these basic problems.